Georg Rath. I'm a systems engineer at IMP IMBA. What we're doing is life sciences, so genomics, bioinformatics, cryo-EM, stuff like this, not necessarily classical HPC. So we set out we wanted to know what actually happens inside the job, so which programs do our users run. For us, the reason was because we took over this cluster from the bioinformatics department. So what's happening there? You have the program execution, you have the... Can you hear me with this? Or?
Yeah.
The shell libraries, and also affecting the outcome of the job is the environment. So why would you want to know that? That's actually an interesting question. Because some of the users run some unoptimized Python they built themselves because they have a tutorial from the internet and run them from your home directory. So we wanted to know about that. We wanted to know if they use some binary build of a software in their groups directory or in their home directory, so that we can maybe optimize their library for the users, like a BLAST library, and this has happened as far as I'm aware. And the library has a bug. How do you inform your users? Which jobs did use the library, stuff like this, and is the environment sane? Is OMP num thread set to the actual amount of slots that the users requested? That something. So how would you do it was an interesting question, because we actually looked at existing solutions, and the first thing we tried, oh look, tension. Too much tension. Is asking the users, and which is the obvious downside that you can't automate this. It's a very nice thing to talk to your users, but in this case it didn't work because you have some shell script that does lots of stuff because it's bioinformatics and life sciences, and this is how these sciences work. You could go through the shell script, check everything, and then rinse and repeat and do this for every group that you have, which in our case are 40. But so you figure out pretty quickly that can't be the way to do it. So we tried hooking to module loads, and then you figure out very quickly that loading a module does not mean using a module. This is actually a live profile from one of our users, several of our users, and they load the modules and they never use them. So every login to an interactive node, every job, you get this problem. Then, this was last year or 2 years ago, there was Exalt, there still is Exalt, which is done by Robert McLeay from Tech. When we started with this, Exalt needed a launcher. As far as I'm aware, it does not need any more, I think, but I'm not 100% sure. It's not designed to track everything because we're greedy bastards, so we wanted to get everything. And it's tailored for the needs of Tech, because it's coming out of Tech. And I found it quite complex to deploy. So you write your own stuff, right? OGRT tracks every program execution there is, every shared object the program loads. It embeds a signature into the program and into the shared objects, which it reads out of memory. So you get not only the name of the program that you execute, but the signature, which you can then link with the build time information. And it outputs the data directly to Elasticsearch or Splunk. We're using Splunk at the moment to be able to publish this and be able to share. We did Elasticsearch, Carlos did a plugin for the server. And what makes it unique, it works without a launcher. How? I'm going to tell you in a second. It's very lightweight, it does everything in memory, and it's very quick. It's transparent to the user. We had it running. I'm not aware that any user noticed it running. It's resistant outside reflex, which means it's not interpreted, it's a C program, so, and it links everything statically, and so nothing interferes with it, and it should not interfere with your workload. It has no runtime dependencies. It's, I think, quite easy to deploy. So another part is, how does it work without a launcher and all this stuff? And the tension is mounting up again. There is LD preload, which is quite nice because you can preload a shared library into every program execution that you load, which in turn does not make this viable for security stuff. It's not a replacement for OGRT because your user can just blank preload. You could theoretically prevent this, but I'm not going to do this. And we combine this with the constructor, so OGRT gets loaded into the address space of the program on every program that you execute. So you run an ls, you run a sed, you run an awk, you run some MPI job, you get it. And then tracking shared object, that one was a bit trickier. But when you're in the address space of a program, you can actually iterate over all the shared object that it has loaded into memory. And the signature you read out of memory because at link time, every shared object that you build, you embed a section into the elf, and you read that out of memory. So the signature, you link in the compiler, I had this, and we're not the first ones to do this. The GCC build ID works the same way. So what you can do is you can do read elf-n, and then you're gonna see that the watermarks that your binary has ABI compatibility gets also done this way. Why the signature? That's also an interesting question. It was interesting to write and it was a nice gimmick. On the other hand, a path to a program does not really tell you which program you're using because it prevents errors. So if the user recompiles the program in the same path, you're gonna know. If you yourself make the mistake of changing an existing library in your production system, you're gonna know. So because everything is done in memory, we're super fast and super lightweight. We're transparent because you don't notice it. The only overhead you had is you create a socket to the server. I'm going to explain first how we persist the gathered data. So there is a client component which you preload into the address space of the program, which is libogrt.so. And there is the server which has configurable outputs, which outputs to Elasticsearch, Splunk, or files. I would not recommend files. It's for debugging purposes only. We have it running in production with Splunk. It also works pretty well with Elasticsearch. The thing is, in my opinion, that's a personal one, Splunk works a bit better if you can afford the licensing. And I'm going to do a demo because I think we're kind of hands-on persons. So can anybody see this? Do you want it smaller or larger, or is this fine? Okay, first we're going to start the infrastructure that we need, which is, of course, behind Docker. Elasticsearch and Kibana, because setting up a Splunk would be a bit much now. So this is running. The next thing we're going to do is, as the server is a Go program, I recommend in general for trying this out, just downloading the static binary and executing it. For the people that are laughing because it's like curl bash, well, yes it is. There is a config file where you configure the outputs. So in this case we're outputting to temporary directory plus to the Elasticsearch. We're going to start the server. You see it instantiated its outputs. And it gives out some statistics. So the client is the important part that is also the hardest to set up. To make this easier to deploy and easier to try out, there is a vendorized script, which I stole from Ruby and Python and virtualenv. It basically downloads the C dependencies, builds them statically, And if you build the software, if it finds this vendor folder and everything's compiled, it uses that. Because I don't want to download stuff, we're not going to do this now, we're just going to configure the thing. To say, the configure option here, you can configure nearly everything. You can configure if it sends the username to the server, sends the host name. You can send the whole environment for every program execution or single environment variables. So whitelist, you can specify which variable it uses to extract the job ID. So when we install that, install it to temp. So it even has tests, which are more smoke tests than unit tests, but they work. Then we preload the thing. Start the bash. So in this bash, you have OGRT loaded, and every command you run is intercepted by it. So if you do an ls, nothing happens because by default it's not active. This is a security measure, so accidents don't happen as easy. If you want to look at how it was compiled, you do this, which you don't see. I ran it from a dirty git, never do this. It's using localhost on port 7971 to transfer to the server. The node section, we're gonna do signatures in a while, is node OGRT info. It sends the username and the hostname, and it does not send the environment. To activate it, we just do this, set the environment active, which means it's active. You get the debug output by default. You need to turn this off as, well, the defaults are you see it and it's not active, and if you really want to deploy this on your system, you need to work a bit to make it transparent to the user. So, of course, if you're going to deploy this, you don't want the output. So there is no silent. This was called something else in the past, but nobody got the joke, so I changed it to silent. So if we do an ls now, it is like we do nothing. You can do ID, we can, what do we want to run? There is a test program which does nothing. Maybe more interesting now would be how this looks in Kibana. So we have our Kibana here, which is totally unconfigured. You write in which index you want to use, which is OGRT. Oops. And then you get, we saw this yesterday, and then you get the programs you ran just now. I'm sorry. So what you see, you get the binary path for, look, it's a display bug. You get the binary path of the test program, you get the host name, you get the job ID, which in this case is unknown because we didn't set the job ID, we're not running in the job. Parent PID of the process, which is interesting now is the shared objects. So this test program did literally nothing. So what it loads is OGRT itself with the signature, because I cheated a bit and OGRT was actually running when I compiled the stuff. libc, the loader, and some NSS stuff, plus the signature of the test program here. So if you would like to see, so you know a library or the signature of a library, and it had a bug, you just take the signature, put it in here on top, press enter, and you see every job that used this library. By the way, I didn't say this in the beginning. If you have any questions, ask them now. If anything's burning under your fingernails, rather than later. So I'd like to show you how the signatures work. So this test, so let's say we have a test program, which is the minimalist program, which is this, which does nothing. If you compile this with GCC now, oh sorry, we're going to call it hello, and you do readelf, you see, let me see, there is the build ID which gets appended by GCC, there is the ABI tag, and then there is this section that readelf does not know about, which is an unknown type. If you take OGRT, which is in the path at the moment, and you want to see the signature, you see there is a signature, it's allocatable, which means it gets loaded into memory. It has the version 1, its name is OGRT, and there is a UID in there. To automatically embed signatures to every program you compile at compile time, there is a wrapper provided for LD, which just wraps LD, generates a signature every time you're running LD, and appends, that's not very readable, and appends the signature to the LD command. So every program you link will have the signature linked in with it. If you then want to build up a database of build time parameters, you will need to modify this wrapper, because this is very, very site specific how you would do that. You could load into Elasticsearch or build a database. In the end, you need to modify this wrapper. Oh, I'm a bit quick. So that would be the demo, unless you want to see more. I guess not. So in conclusion, because I really was way too quick, is OGRT gives you really deep insight what runs on your machine. You get everything, which may be too much. It depends on what you use it for. It's very versatile because you can use it for lots and lots of things, not only for monitoring jobs, but for other stuff. It's configurable. You can configure what it sends and what it doesn't send, and it's very easy to deploy. Because I cheated a bit, but if you would start now on your laptop, you would probably be done in 10 minutes. What you can do with it, you can provide a sense of used software. If you have a module system like LMod can generate a reverse map, which contains every program that you have in your module tree, and then you can go back from the binary path to the module. You can troubleshoot problems with the user program picking up unexpected libraries. So this can happen with the module system, that the user expects his program to use the library that he has in his home directory, or the system library, or one from the module, and it picks up a different one. You can retroactively inform the users about buggy libraries, and you can compare, if you have a production pipeline, runs of programs. So you can see job number 1 compared to job number 100, which is the same pipeline. What changed? Did it run the same programs? Stuff like this. There is an outlook. What could be done to OGRT, what will be done. Probably some of you don't like the server part because we have a perfectly good system, why don't we use that? And that's a very valid point. I would be glad if somebody hits me up which format you put the data in there. Do you put JSON? Do you this is something we need to figure out, but it should be reasonably trivial to implement. Filtering in preload libraries. I said you get everything, and everything is a lot, which makes it very nice because you see anomalies pretty quickly, because in our case we had job submit verification of the grid engine acting a bit strange. You get this, but it's a lot of data. It depends if you want this or not. We could put in filtering. The question is, how do you filter? And this would need to be figured out. I'm happy for input. Another thing to do would be database level compatibility with Exalt, because that would actually be possible, because fundamentally it is the same data. There is another thing that I stumbled up recently, which is eBPF, which is from Brandon Gregg. He does the Linux tracing framework magic stuff. You need a pretty recent kernel for that, but that should be even quicker. Maybe in the future. What you could also do, but this is going into the direction of actually a tracing framework, and it's not so quick on the roadmap. You could do symbol level tracking, which means the program that I run, did it use the function XYZ? You could do this by hijacking the loader, because the loader needs to lazily pulls in the symbols for this function. So you could do that. If anybody is interested in that, I'm gladly set issues on our GitHub. And thank you. This is the end of the presentation. There is a GitHub repository. If you want to check it out, if you're missing features, if you're having bugs, open issues and pull requests, we're happy for any contributions that we get. Thanks.